Hello everyone, I'm Haider. Today I'm here to present my research which is about investigating haloacetonitrile formation potential from nitrogen-based antibiotic and agrochemicals. As we all know, chlorine and chloramine are the most common disinfectant used in the treated water in order to reduce the pathogenic infection. But this disinfectant can produce unwanted disinfection byproducts upon reaction with organic matter present in the water. This organic matter which can produce the unwanted disinfection byproduct is known as the precursor for the disinfection byproducts. So far, there have been identified 700 DBPs which can cause cancer related problem for human. So the most common types of DBPs includes trihalomethanes, haloacetic acid, nitrosamine, and haloacetonitriles. Even though the haloacetonitriles has been found more toxic than the other regulated counterparts of trihalomethanes and haloacetic acids, the haloacetonitriles are not been regulated yet. Nitrogenous organic matter are abundant in environment, but it can also be introduced to water through anthropogenic sources such as use of nitrogen-based antibiotics and agrochemicals. Due to the extensive use and the lower biodegradability, they can always make their ways into the water bodies. And currently, there are no such treatment technologies which can effectively remove them from the water bodies. So the main objective of my study is to investigate the formation potential of haloacetonitrile from these anthropogenic nitrogenous compounds for both disinfection process, chlorination and chloramination. I want to also investigate the formation and the degradation mechanism of these model compounds upon chlorination and chloramination. And finally, I will quantify the haloacetonitrile for both chlorination and chloramination. To accomplish the objectives of my research, I have came up with several research questions. The first research question I have is that do the presence of secondary amine or aniline will in the structure have the potential to form haloacetonitrile upon chlorination and chloramination. The hypothesis behind that is that pharmaceutical or the agrochemicals with sulfonamide group will yield more haloacetonitrile than the secondary amine or aniline alone. The longer bond between sulfur and carbon and sulfur versus the carbon and nitrogen will facilitate the electrophilic substitution and ring cleavage reaction. And the compounds with the secondary amine with the aromatic ring in their structure will facilitate more haloacetonitriles through ring cleavage reaction. The second research question is that how will the presence of bromide will affect the formation of haloacetonitrile during chlorination or chloramination of nitrogenous compound. As we all know, the bromine has the higher affinity for chlorine substitution. Consequently, the presence of bromide will facilitate more brominated haloacetonitriles in the water. The final research question will be how will the initial dose of precursor and the disinfection will affect the formation potential. So it is expected that the higher the dose, the higher the formation. For my research, I have chosen most commonly used nitrogen-based agrochemicals, shimazine, atrazine, and carbyl as a representative of agrochemicals, and frequently used antibiotics of the recent times, sulfaxazole, sulfanilamide, and sulfactamide has been chosen as a representative of antibiotic. My test will be conducted on synthetic wastewater, and the FP test will be performed on that water. Then after the desired time period has been passed, the sample will be extracted through liquid extraction, and then the extract will be analyzed through gas chromatography mass spectrometry. So far, the previous literature have shown that the aromatic structures such like aniline and phenol have the potential to form haloacetonitriles upon chlorination. And another study shows that the amino acids have the potential to form trichloroacetonitrile and dichloroacetonitrile upon chloramination. So it can be anticipated that my model compounds will yield haloacetonitrile. The potential significance of my study is that it will provide information about the formation potential of haloacetonitrile from anthropogenic compounds, and this result will fill the void about the precursor knowledge of precursor about the haloacetonitrile. Thank you.